Hello my dear viewers. Now we'll develop our concept or in vector product or cross product of two vectors. In earlier classes we have discussed the product of two vectors are two types. One is the scalar product where we found that product is coming a scalar quantity. Now we'll see the product of two vectors is a vector quantity and how it comes. Here we'll write this by cross. Initially we learned A dot B. Now we will learn A cross B. We define this as vector A magnitude of vector B. So magnitude of vector A into magnitude of vector B. Now we take the angle. Instead of cos theta, it is sin theta, and since there is an effect, it has a direction, and we are writing by n cap, where theta is the angle between vector A and vector B, and n cap is a unit vector perpendicular to the plane of vector A and vector B. Look at this picture. Here we have taken vector A and vector B. So this is the plane, and look, n cap is perpendicular to the plane of A and B. And this practically, if you see, when you using a screwdriver, when you fix up a nail, and when you rotate like this, and the point tip of the nail moves downwards. If you rotate a fan, we say the wind comes downwards perpendicularly. So this is the effect of vector product. Now, vector product or cross product here we defined as vector A, vector B sin theta into n cap, and n cap is perpendicular to the plane of A and B. Now if you define B cross A, if you write B cross A, then it is coming vector B, vector A sin theta. Theta is angle hypotenuse. But here there is a change. Instead of it goes perpendicular above, now the direction is changed opposite to n cap. It is minus n cap. So that's why the cross product A cross B not equal to B cross A. What we found, A dot B is equals to B dot A. So dot product is commutative, but cross product is not commutative. Now if next property is if either A or B is 0, then A cross B will be 0. In that case, the angle between them, that is theta, is not well defined. If A and B are collinear or parallel, then the theta is either 0 degree or 180 degree. In that case also, theta is not well defined, but we write A cross B is equals to 0. Next one, so we can write that if A and B are non-zero vectors, but but A cross B is equals to 0. So A and B are non-zero, but their product is coming 0 vector. So obviously it must be the sine theta is 0 there, or theta is equals to 0 degree. That means A and B are collinear or vector A is parallel to vector B. Now, if two vectors are A and B are perpendicular, in that case, their cross product will be A, B sine theta into n cap. But you know sine 90 is equals to 1. So we are getting A cross B is equals to magnitude of A into magnitude of B in n cap. So from here, you can write that n cap is equals to A cross B by magnitude of A into magnitude of B. Next property, you can define sine theta as a mod of A cross B by magnitude of A into magnitude of B. Why we put the mod sign? Because it is a scalar quantity. A cross B is a vector quantity, so you put the magnitude of A cross B by magnitude of B. Now, if you look at this, along x-axis we define I cap, the unit vector, along y-axis j cap, and along y-axis k cap, z-axis. So now we'll check what are the relation between their cross product. I cross I. By definition, this is magnitude of I, again magnitude of I cap, sine, here the sine 0 degree. So 1 into 1 into 0, ultimately we are getting the 0. So I cross I is 0 degree. Similarly, j cross 0 and k cross k cap also 0. What about I cross j? As you know, the cross product, the direction is perpendicular to the plane of I and j. So, and the plane of I and j, we have found the unit vector k cap. So we can write this is equals to k cap. Similarly, j cross k, you can do this picture I, j, k. If we place in a circular manner, then we'll say I cross j is coming k, then j cross k will get I cap, and k cross I cap will get j cap. But if we do the reverse, we'll get the negative j cross I will get minus of k cap. The direction will be changed to opposite. Now it is j cross k, so k cross j cap is equals to minus I cap, and reverse this. Now we'll give a formula to calculate A cross B. It will be I, J, K. If we take components of vector A as A1I, A2J, A3K. So these components will put in the second row of the determinant. And if we consider vector B as B1I cap, B2 J cap, B3 K cap. So third row will complete with B1, B2, B3. So the value of the determinant define the value of the A cross B. Another one can use the distributive law here. Law is applicable. That is, we do the cross product of here. So we get A cross B plus A cross C. B minus C to do A cross B minus A cross C. Okay, thank you.
For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.